Talk about how to translate functions. So basically, translate means to move. So we can move them, we can shrink them, we can stretch them, but it's going to be the same shape, just in a different place, all right? The graphs will probably translate the most, will probably be the parabola and the absolute value. And periodically, we'll do the square root graph. So when we translate them, we want to translate their vertex, and that's not really a vertex, but it's kind of like an endpoint. Then it makes it pretty easy. One of the things I haven't talked about real quick is odd and even functions. Odd, just like that, and even, just like the word says, if it's even, for instance, if it's a y equals x squared, that's an even exponent. So if it's an even function, if you plug in negative f of x, if you make x negative, it'll turn out to be just the original as a positive f of x. That makes an even function. But an easier way to determine if it's even is this. If you took an even function and you spun it around the y-axis, and if it spins onto itself, if it's a reflection of itself, it's even, okay? That's the easiest way of all. If it spins onto itself, okay? Odd, just like, if I have a y equals, say, an x cubed, say, minus a 9x, the exponents are odd, but not all of them are odd. Yeah, Quinn? Sure. So, if I were to plug in negative f of x, make every x negative, it would make the whole function negative. But an easier definition is if you were to spin this 180 degrees, like a pinwheel, like take it and just spin it 180 degrees, go 180 degrees, and if it spins onto itself, that's the easiest way to know whether it's odd or even, okay? You'll see this in calculus. You won't see it a lot in here, but it's good that you know what an odd and even function is. Okay, let's go into our notes. So we're going to take these and we're going to translate these. So pass out the notes real quick. I probably should have waited to push the forward, so I'll let you guys just pass those out. Pass those out. Pass those out. And I think you're going to need extras around here somewhere, but pass those out. Pass them out. I don't know if we have enough. Make sure everybody gets one. If you don't, let me know. Okay? Are we good? Everybody have one? Good. The extras, just hang on to the extras. I'll get them later. Okay, so topic. What we're going to do is how to translate functions. Okay, so first of all, we're going to start with what we call the parent function. I guess it's a fancy way for saying the basic function, okay, so the basic graph. Now we move it. So if fx equals x squared, we were looking at that on Friday, and it's just the parabola. And remember how we did the 1, 1, 2, 4, 3, 9, because those are 1 squared, 2 squared, 3 squared. So if we were to put that back, we know the vertex is at 0, 0. And we're just going to put the parent function here. 1 squared is 1. Then back to the vertex. If I go over 1, 2, 2 squared is 4. So go up 1, 2, 3, 4. This is the easiest way to graph the parabola. We can go over 1, 2, 3, and 3 squared is 9. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And the nice thing about the parabola is we know it's symmetrical with the y-axis, which means it's an even function. So I can put a point over here, a point here, and a point here, and then just draw in my parabola. Okay. Curvy. They're not pointy. They're curvy. Okay. Now, here it is. Let's move this. So, question A, f of x minus 4. All we're going to do is pull our function down 4. We're going to take this function and just go down 1, 2, 3, 4. f of x minus 4. Bring it down 4. Exact same graph. We're not going to change anything else except for to bring it down 4. So, we're going to go 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, it's symmetrical on the other side. So all we did was we took our parabola, our parent function, and just moved it down 4 on the y-axis. There we go. That's it. B. Two things are going to happen with B. Two things. One, it's going to be upside down. It's a reflection. It's a reflection over the x-axis because of the negative on the outside. The second thing is it's going to be twice as tall. So how do you make it twice as tall when it's already tall? I mean, one could argue that, well, it has a height of infinity. But what's going to happen is its individual y-axes are going to be twice as high on its individual y-axis. Okay, so check it out. Here's how I'm going to do it, okay? I know it's upside down, right? So normally I'd go 1, 1, but I'm going to go twice as tall as 1, 1. I go 1, 2, but upside down because of the negative. So instead of going 1, 1, I'm going to go 1, 2, so I'm going to put it there. Twice as tall, okay, because of the 2. Instead of going 2, 4, like 1, 2, 3, 4, it's going to be twice as tall, so 4, 5, 6, 7, 8. Now I'm going to run out of room to do the other one because it's going to be 3, 18. Because I go 3, 9, but 3, 18 is like, so I'm just going to put the other dots in here. So it kind of makes it skinnier. Some people would say it's taller. So I made it upside down because of the negative. And I made its y values be twice as tall or twice as large. Okay. All right. Now you have to be careful. This one's going to be a horizontal shift, but it's going to be the opposite. Okay. In our reading, I put opposite. So in math, a negative or subtract means opposite. Okay, it always does. So instead of shifting this one back 3, you'd think back 3, wouldn't you? It's like x minus 3, move back 3. It's just going to be the opposite. We're going to go to the right 3. We're going to go to the right, okay? And I'm going to tell you why when I get done putting it. So I'm going to take this graph, my parabola. So the vertex being here at 0, 0, the vertex is going to be at 3, 0. So I'm going to take it and put the vertex right there. Now why? I don't know, who cares why? Well, I do, actually. I care why. If x were 3, put 3 in here. What's 3 minus 3? 0. So it zeroes it out. Does that make sense? And the vertex is the very bottom point, okay? That's why it works. So now we're going to do the same thing. All we did is we took this parabola, we moved it to the right 3, and we're going to graph it like we always do. We're going to do my 1, 1, my 2, 1, 2, 3, 4, my 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It has an axis of symmetry. Oh, fancy word. Axis of symmetry. You don't need to draw this in, but I'm just going to reflect over that line because we know what the parabola looks like, right? So my other coordinate is there. I've got another coordinate here and one more coordinate up here, and there's my parabola. So I just moved it to the right. I went the opposite, right? Opposite. I'm going to highlight that. So if it's a horizontal shift on the inside, it's going to be the opposite, okay? All right. D. So on D, with a 2 on the inside, what we have to do is, actually it's going to make it half as wide. This is really confusing, but I'm going to teach this to you several times this year. If it's on the inside, it's always the opposite. So it's going to be half as wide because you need to fit 2 curves in the space of 1. I'll say it again. We need 2 curves in the space of 1. We got to get 2 of these curves in the space of 1. Well, the only way you're going to get 2 curves is to make it half as wide so you can fit both in, okay? So what you're going to need to do is get 2 curves. And to get 2 curves, you're going to make it half as wide. So you're going to make it half as wide. That's the only way we're going to get 2 curves. All right, we'll talk about this again when we start doing trigonometry, okay? So we're going to take our shape, right, our basic parabola shape, and we're going to have to make it half as wide so we can fit 2 in the space of 1. So instead of going 1, 1, I'm going to go 1, half, 1. Half as wide, okay? So instead of going 1, 1, I'll go half and 1. Instead of going 2, 4, so going 2, 4, I'm going to go 1 and 1, 2, 3, 4. So making it half as wide, okay? So going over 1, 2, 3, I'm going to go half as wide. So I'm going to go 1 and a half and 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? And of course I'm going to reflect the points to get the other ones over the y-axis. Okay, so it's skinnier, but what happens is that really we could fit two of these curves in the space of one. That's how it works. All right, F. So we're going to do three things on F, but don't worry, it's not that big a deal. First of all, we're going to take the vertex, and we're going to move the vertex to -3, -5. Okay, opposite of the inside, right? So we're going to take this parabola and we're going to move it to -3, 5. So we're going to go 1, 2, 3, -3, and then 1, 2, 3, 4, 5. So I'm going to go right here, -3, -5. Okay. Oh, I'm going to run out of graph. That's okay. I'll be creative. And I'm going to make it half as tall. Okay. So now at least I have the vertex, -3, opposite of that, -5. Then I'll make it half as tall, okay, because the factor is a 1/2 factor for the graph. Okay, that's not bad. So am I going too fast? Okay. So instead of going 1, 1 from here, half as tall, I'm going to go 1, 1/2, half as tall. So you're going 2, 4, 1, 2, 3, 4. I'm going to go half as tall, so 2, 1, 2. Okay. So going 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going half as tall, so I'm going 3, 4.5. 1, 2, 3, 4.5. Okay, and then I'm just going to go ahead and reflect it over this line of symmetry. There's its line of symmetry, so I can reflect these points and reflect this point. Okay. Now, the good news, I suppose, is that get into a test and it's okay. Say, I can't remember how to do this, Mr. Davies. I'm clueless. I'm stuck. You can put them on your calculator, right? Does that make sense? Even this one right here, if I go a 1/2, check it out, 1/2, and if I go got to do it, and I'm doing my x squared, so I got to go an x, check it out, I'm going to go x plus 3 squared, because it's x squared. That's my function, right? X squared. Then subtract 5. And there it is, right? Same graph. So if you get into a quiz and you're a little stuck, you can always put it in the calculator, right? That helps. Helps a lot. Okay, now let's shift over. Now, but the bummer is on the next one, you can't put it in the calculator. But we're going to use our brains. So you got a picture. It's a function. It is a function, right? And what we want to do on this one is the same things. So we've got to use our brains. We can't put it in the calculator. We're smart, though. Okay, the 2 on the inside means we're going to have to put 2 curves in the space of 1, so we're going to make it half as wide, okay? Because you really need to put 2 of these curves in the space of 1. How do you do that? Well, let's check it out. So, instead of going over here, right here, where it crosses the y-axis, it slides across 1, right? See how the point slides across 1? But we're going to make it half as wide. So instead of going all the way across 1, we're going to go to about a half, right? This point right here, do you see this point right here, is over 2. So instead of going over 2, let's do half as wide. So we're going to go over 1. Okay, this point right here goes over 3 to that -1 value. So instead of going over 3, let's go over 1.5 and a height of -1. This point goes over 1, 2, 3, 4, but instead of going all the way to 4, we're going to go half as wide, so we'll go 1, 2. This point right here goes over 1, 2, 3, 4, 5, but it's half as wide, so let's go to 2.5. 1, 2, 2.5, okay? Now, let's go backwards. So this has a coordinate at -1, but we're going to go half as wide, so we'll go to -1/2. Let's go to this point at -1. So you got to go back to, we're going to go half as wide, so we're going to go back to -1. This coordinate is at 1, 2, 3, back 3. We're going to go half as wide, so we're going to go 1.5. 1.5. This coordinate's at 1, 2, 3, 4. We're going to go half of that, so we're going to go 2. 1, 2. And this one is going to go all the way out at 1, 2, 3, 4, 5. We're going to go half of 2.5. 1, 2.5, and it's up here. All right, let's check it out. Let's see what we get. We get a picture that looks like this. Okay. Now, if I were to keep drawing this again and just let it keep going, then I could get two of these curves in the exact same width as one of these. I'll say it again. If I drew another one of these, I would get two curves in the span of the originals. That makes sense. But to get two of these in the span of one of these, you'd have to make it half as wide, okay? Well, then B, what do you think B means with the 1/2 here?
Twice as wide.
It's got to be twice as wide. You're going to get half a curve in the space of one. So exactly right. So this is going to be, so we need half a curve. But the big thing is totally right. Glide work, it's going to be twice as wide. Okay, twice as wide. Let's see what that looks like, okay? All right, let's go back to the original. It's actually not so bad. I know this point. You know why I like to put this point down first? Because if it's at 0, half of 0 is still 0. Twice 0 is still 0. 5 times 0 is still 0. So I like to start with my 0 one because it's not going to change. My 0 one's going to stay 0, right? So let's make it twice as wide. So this one goes out to 1, so now all of a sudden it's going to go out to 2. See how I'm making it twice as wide? This x-intercept goes to 2, but now let's make it go 4. It goes all the way out to here, all right? See, it's looking twice as wide. This one goes to 3, so we got to 6, which I may not even fit. 1, 2, 3, 4, 5, 6. It's about all I'm going to get because I'm only going to get half a curve, right? I'm only going to get half of it. Okay, let's go negative. If I go back to -1, that's 1 square, but I'm going to go twice as wide, so I'm going to go 1, 2 to here. And if I'm going to go to this -1, I've got to go back 2, but now I'm going to go twice as wide, so I'm going to go 4. 1, 2, 3, 4, and so forth. Now, really, what we get is this. Check it out. It's kind of cool because we only have really about this much of the curve, right? Which is about half of it, right? We only have about half the curve graphed, right? So to get half the curve, it's got to be twice as wide. Okay, last but not least, we're almost there, huh, on these graphs. If it's on the inside, my reading says we're going to flip it over the x-axis, right? So I'm going to take it and turn it, take this graph like a barbecuer and flip it over the x. That makes sense? We're just going to take and flip it over the x-axis. So that's not so bad. So this piece right here is going to go over there. See how this piece right here goes over there. All right. This piece coming down is going to go over on the other side. So it means this piece right here is over on this other side, okay? And then this piece right there goes there. So I've got most of this flipped, all right? Let's go to this back side on the negative side, flips over to the positive side, so this piece has to go down here. All right, see how this piece goes there. Got this piece there. Okay. All right. Last example. Determine if functions even or odd. The easiest way to do it is by graphing, okay? I'll graph, and if you guys just want to watch, you guys are pretty good at using the calculators. So I'll do them, you can just watch. So first of all, it looks like it's probably odd. Odd exponents, right? Probably odd, but let's double check it. Remember, to be odd, it has to rotate 180 degrees around the origin, okay? Around the origin. Let's see what that does. Y equals, clear, x to the 5th power plus x. Let's check it out. Graph. Ready? Set. Boom. Alright. So if I were to take like a pinwheel and spin it 180 degrees, does it spin onto itself? Yes, from the origin. So it is odd, definitely. Odd. Yes. Odd. Has to spin from the origin though, and if it spins from the origin 180 degrees, it's odd.
So it won't line up?
It will. This will. It will. It'll spin 100. This one definitely will. If you take and spin it, it spins onto itself. Can you see it? Like a pin will go. Can you guys see that? Visualize just going. Here, watch. I just take this and go 180 degrees. It spins onto itself, doesn't it? Yes, it's odd. Okay. Let's look at the next one. Okay. Looks like it might be even because of the even exponent, but let's check it out. So with even, it's got to be a reflection over the y-axis. Well, let's see if I get that, all right? All right, clear. 1 subtract x to the 4th. All right, if you were to spin that, if you were to flip it over the y, does it flip onto itself? Yeah, that one's even. So yes, this one's even. Okay, the last one. I don't think the last one's going to work. I'll tell you why. I've got an even exponent, and I have a odd exponent. It's probably going to be neither. So I'm pretty sure it's going to be neither, but let's look at it anyway, okay? Let's see what it looks like. Okay, y equals, clear, a 2x minus an x squared. Probably isn't going to work, but I want to look at it anyway. Okay, and there it is. So, if I were to spin this, remember, you got to reflect it. If I reflect it over the, it doesn't reflect onto itself. In fact, you can see it if I just trace it in. Let's see. Don't use a permanent marker. Do I have a marker that's going to work? Let's make sure this doesn't. A lot of you can erase. Oh, good. That's what I wanted. So if I were to spin this, it's going to look like this. If this spins onto it, it's going to look like this. Do you see it? If I drew it? That does not flip onto itself, does it? And if you flip it, go 180 degrees, it's definitely not. So this is neither. This is neither odd nor even. So it's just plain old neither. Okay. That's it for today. All right.